Jantic Journal coming back at you guys with a motor build series. Starting fresh. Brand new engines out of the box. So here's what we got. A couple Briggs Intek, what are they, 23 horsepower, 44 cubic inch, and they are the 2-barrel carburetor style. So plans for these motors, a fairly mild build. I mean, we're going to go with cams, connecting rods, flywheels, all that stuff, but not going to go too crazy with the heads. Just looking for some good power, but reliability, nothing that's going to be too finicky. So this video, I'm going to start disassembling the engines, show you guys how they come factory, what to expect if you order a brand new engine. I've never ordered a brand new engine before. And then mostly my goal is to get the heads off, CC the heads, figure out what kind of compression ratio they come with stock, and then do a little bit of head work, set my compression ratio, clean up a little bit around where the valve springs and all that are. I'll show you what we got to do with that to put in the dual valve springs. And I'm not going to call it porting, but probably just, cleaning up the casting marks and stuff like that in the heads. Well, I was going to do some montage type stuff in this video, but I can't find the mount for the old tripod, so we're going to go a little bit, we're going to go vlog style here. But this is what you get for a fuel hookup. Comes with a looks like a fuel pump style filter, I'm assuming. Of course it's Briggs. Got the oil filter. It's got studs for your exhaust, and they also came with exhaust gaskets. This is what you got, your whole governor linkage setup. Fuel pump, of course. I don't know why I was wondering what type of filter that was. The pump's right there. And that's pretty much your hookups. Let's check out the starter. The starter is, just the regular stud and whatnot. I'm not sure what type of plug this would be used on. We're going to end up not using probably any of this, except for, all we're going to need is a kill wire, which is maybe right there. So I wrapped this tape on here, wrapped some tape on the crankshaft, a couple wraps of electrical tape just to keep it from getting marred up. You don't want to start with that. So that's it. I'm going to start taking it apart, and if I see something interesting, I'll show you guys during that process. Otherwise, I'm not going to detail every single little thing. There's not a whole lot. You unbolt the thing and you get to where you need to get to. So we'll see where we end up next. Getting down into the engine here, noticing a couple differences. Nothing too major. This airbox, of course, you could tell that right off the top. These actually seem like a really good stock setup. So I'm just putting all my stuff in the going to use pile, in the not going to use, or most likely not going to use. Probably use that starter for something else. But when you're taking your motors apart, make sure on the twin cylinders, you got to use these diodes. So I'm going to go ahead and clip that at that end. And what this does is it makes it so the coils work properly. I don't know exactly how it works, but if you don't have it, like one coil shorts out to the other somehow. So make sure you use that. What else? Everything's gasketed on these. I'm sorry, liquid gasket, Permatex style on these motors. They don't seem to be using the paper fiber gaskets anymore. And also where your crankcase vent PCV type deal is plastic. So that's different. But gonna go ahead and take the heads off and get into the actual motor. Alrighty, we're starting to get deep into it now. You can see we got the keep pile and the don't know what to do with pile. The Permatex trend has continued. Valve cover gaskets are also Permatexed. The intake gaskets are legitimate gaskets though. They actually came apart pretty good. They didn't want to peel off or anything. New motor, these have never been fired. Also, I think a lot of you guys probably watch the channel and know what it's about, but I should mention these are used for lawnmower racing. I don't think I even mentioned that yet. I'm going to be doing the BP class in the US LMRA series. So I'm going to go ahead and take these, take the rocker arms out. I am not going to I don't plan on using the rocker arms. The cam guy said I could if I wanted to. I don't plan on it. I already got the different push rods that I'm going to have to cut to length. So basically, the valves are going to be reused. I also have new valve spring retainers on the way. So all I'm really going to use in the heads is the valves themselves. So I'm going to go ahead and take all these off, pop the heads off, and let's see what's going on inside. We're right into it now. Check out how rusty those intake valves are. So the trend of the Permatex ended with the head gaskets. Those were actual head gaskets. The graphite style, I guess it's graphite. These style here, they kind of make a mess. I don't know how they're going to seal with the higher compression. I'm not sure if I'm using those or copper yet. But here's what I got going on. I am in the middle of getting to the business of checking the compression ratio. What I'm doing right now is have my dial indicator on here to determine when my piston is at top dead center. And when it's at top dead center, what I'm going to do is slide a feeler gauge under. This is just a parallel for the Bridgeport, just for machining and whatnot. What I'm going to do is slide a feeler gauge, which I should have ready. I don't. Slide a feeler gauge under here to figure out how close the piston is getting to the deck. It's otherwise known as how far in the hole the piston is. This is an important measurement for determining the compression ratio. So I've actually got my feeler gauge out and could just barely, I'm trying to do it one-handed, and the thing is I might pop the parallel up, but I can just barely get the 5,000s, yeah, it moved. Barely get it under this side, and I'm thinking this side, the deck is completely flush. So, I mean, I'm going to take a measurement of just say like 2,000s. I'm really surprised. I thought they were going to be in pretty far. So that's one of the measurements. I have to CC the head. And then also, well, this is a perfect opportunity. You can see how dished that piston is with a parallel going across it. So I also need to figure out the volume of the piston. So I'm going to go ahead and next up you're going to see me CCing the piston and the stock head. That is a nasty fly cut too. We're in the Jantic Journal lab right now. We got the green stuff in the tube. So yeah, I'm just trying to figure out exactly the volume. It was a little bit of a pain in this piston. There's not a whole lot of volume in there, so it's hard to get the stuff to flow in where you want it. We do is just take some Vaseline, put a film around the edge of it. That'll seal the, it's rubbing alcohol. It's just green rubbing alcohol. Looks cool though. Winter green. So, yeah, just filled it up. I got 4 cc's. I started at 62, down to 66. I might take like half a cc out for spillage. So I'm gonna figure the dish on these pistons. I'll probably do it again just to verify. But I'm gonna go ahead and call it 3.5. I'll probably take half a cc out for spillage. So that's the piston. I'm not gonna measure each piston. And next it'll be onto the heads. See what we got for volume in these guys. So I'm actually going to call that 4 cc's on these dished pistons. I don't know if that's a part number for you guys to reference at 6305. But yeah, that's a legit 4 cc's. I did it twice. No accounting for spillage. Couple things. One, I took the valves out, and I'm going to go ahead and Vaseline up the valve seats a little bit, or just the valves so it seals in the seats. I tried to zoom in. You can't really see it, but there's a good ridge there. I probably should take that out before I start factoring in cc's, but it's not that serious for what I'm doing. I'm gonna basically plan on leaving the combustion chamber exactly as is. So you got to use the correct valves. Like if you're switching to stainless steel valves, I don't think they have the dish in them. They may or they may not. I don't think so though. So you got to CC them with the exact valves you're going to use, and also spark plugs. These 2 spark plugs, this is what came factory, and this is what I'm planning on using. I mean, geez, that could easily be good for easily a CC right there. So, got to use your spark plugs, valves, everything, and so we're going to go ahead and Vaseline this up. Put the plate on the top, see what kind of CCs we got, and for these, there could be a variance in them, so I'm going to do all of them. The pistons, there's not going to be much variance, if any. So I am going to CC all the heads. Let's see what we got. So this is what the operation looks like with the liquid in there. Spark plug, as you can see, Vaseline, everything, sealing it up nice. So I filled it up, and I'm giving it a minute just to make sure there's no leak down, but it hasn't leaked down yet. So I know I have an accurate reading. Started at the 10 line. I'm not even sure if you guys can see this, but if I put it in the light like that, started at the 10 and got down to 48.3, or no, well, that'd be 48 and a half. So that's 38 and a half cc's. So I'm going to go ahead and mark that down, repeat the process 3 more times. Then only other measurements I'm going to need is the head gasket thickness and bore and stroke, of course, and break out the calculator. See what we got for stock compression ratios. We got all the heads cc'd. Smallest head is 38.5, largest is 40.4. That 38.5 is like a full cc smaller than the next closest. The other 3 were all pretty darn close. So those values of that difference in cc of the heads equals compression ratios. These are the ratios we have, and this is the range. The highest compression ratio is 8.78 to 1, of course belonging to the smaller head, and the largest is, or the lowest ratio rather, is 8.47 to the largest head. And I use this app on my phone. It was like one of the first apps that popped up. But one of the methods has exactly what I need. It even gives a value for piston dish. The only kicker is you got to do everything in cc's, everything in metric or everything in SAE. So you got to do a little bit of translating. So now let me get into the theory of what we got to do next. Let's just call it 8.5 to 1 compression ratio. That's a little low. I'm looking to get close to 10.5 to 1. 10.25 to 1, I'll take that. These aren't real crazy race motors. I want to run them on regular pump gas. So to get the higher ratio, I'm not going to take any volume off the decks. One, I don't want to touch the blocks, and 2, the pistons already pop all the way up. I'm running stock length rods. Oh, here's the aftermarket rod. ARC, the good stuff, aftermarket, compared to the stock one. Tell you what, the stock ones on my stock motor held up pretty good, didn't let go. So I'm running stock length rods. They make longer ones, and then you can cut these pistons down or get custom ones to flatten them out. That helps your compression right off the bat. But what I'm going to be doing is taking material off of the head. So the reason I put this gasket on is I want to show you this gasket is pretty much the same inside diameter as the bore, the cylinder bore. And as you can see, the actual combustion chamber of the head is considerably smaller than what the bore is. So it's not as simple of an equation as, do some math and figure out if you want to gain, let's just say I need to lose, 5 cc's. Let's just say that's the number. It's not simple to know how much material to take off the head because it's not a cylinder, and then it changes as you cut down. So for example, the first 20 thousandths you're going to be removing pretty much just this outer rim, right? Let's say approximately 20 thousandths. So that's going to gain you a lot of cc's. But then once you cut down, let's say we had to cut all the way down to here, well then you have to take account as to how big the amount of volume that you're removing is. So, at first I might be removing 95% of the volume. So for every, 100 thousandths or 10 thousandths I cut, it'll be like 90% of a cylinder. That's pretty easy to calculate. But then once you start getting into this odd shape here, you're really guessing. So I'm going to be guessing, let's say I'm taking off 75% of a cylinder. That's going to be my educated guess for knowing how much material to take off. I don't want to take off too much, so I'm going to be coming back and forth. I'll take a good whack at it on the Bridgeport. We got the mill over there. I'll take a good whack at it and then see what kind of volume it comes out to. Another thing I'm afraid of, and I don't think it's going to get that crazy because I don't have the big boy cam. I just got like the regular cheetah cam. I don't even have it yet, but it's coming in. The piston to valve clearance. That's something that could get iffy. But we're just going to go for the set compression ratio that I'm looking for and hope that the valves don't get too close. I know they did on that Predator build I did years ago, that Hemi Predator, but those are canted valves. So the let's just call it the outside of the canted valve already starts much closer to the piston. These are flat, so the whole piston sits back a lot more. So I'm not anticipating interference issues, but it's in the back of my mind. So this is the head jigged up in the Bridgeport with a fly cutter attachment. So I did put 30 cc's of alcohol in here with the valves in and spark plug. And boy, I'm gonna have to take quite a bit of material to get what I need. I need to actually take 10 cc's out of this. 30 cc head is the number. Probably not gonna get there. As a matter of fact, with the spark plug, you know, no spacers, just as is, the spark plug is sitting about 80 thousandths below the current level here. So basically gonna just take 80 thousandths off right now. Of course, at 80 thousandths there, I still have the 32 thousandths of the head gasket, so you know it's not going to be hitting the piston. But for now, I'm going to take 80 off, and I'll probably do another volume test right in the mill. So let's turn this thing on. So this is the head after one pass, doing 20 thousandths each. Each pass, I'm going to have to make 2 swings at it. I can't get it in just one. So on my final pass, I'm going to prioritize the combustion chamber where the gasket seals. So, you know, I'm going to do my main pass, and my second pass is only going to be this little bit here, which isn't where the cylinder, real cylinder pressure is going to be. That's just kind of where for oil leakage. So I'm going to go ahead and do a one-handed operation here. That's 20 thousandths, and like I said, second pass, so we're down 40 thousandths here. Do 2 more passes, get it down to 80, see what we got. Also, you can see the machining marks going both ways. So going in this arc and also that arc. That means that I got the head, or the machine actually very, very well squared to the table, so that's good. Otherwise, if it's cutting more on one side than the other, it's not square and you're actually going to have it slightly U-shaped. So that's pretty good. Again, this is only 40 down, so boy, I'm thinking I might CC it after 60. I'm getting a little bit nervous because it's hard to put the material back on, but easy to take it off. So let's see what we got. And this is what we ended up with, 80 thousandths off of the top. So I had to make 2 passes at it. Don't have a fly cutter wide enough to do the whole thing. I'd like to have done the whole thing in one, but had to finish up on this. You know, you see a difference in finish here, but you know, there's nothing you can feel to the touch. Plus, I'm gonna put this on a nice block. I might order a granite block and give it a good sand anyways. So that's 80 thousandths off, which reduced it by 8.2 cc's. So I didn't get to the 30 that I wanted to get the 10.5 compression ratio, 10.5 to 1. 32 cc's comes out to basically 10 to 1. That's cool. I'll roll with that. The last 20 thousandths pass I did, basically all of this area was already cut away. So the last 20 thousandths, but basically if I took another 20 thousandths on this, it probably would have reduced 1 cc because I checked it at 60 thousandths. So basically if I wanted to get to 30, I probably would have had to take in another 40 thousandths for a total of 120. Didn't want to go that far. If I took 40 more, the spark plug would be hitting the piston anyways. So anyways, that's what we got. I'm going to have to make a little bit of adjustments because, you know, this one starts at 39.6. Actually, that one starts at 38.5. So I'm going to have to take less material off of those heads so that they're all even. I want them all at 32. I don't want, you know, one bank higher than the other. And that's going to do it for this video. Next time I'm going to finish up the heads, have a little bit more work to do. Setting up where the intake manifold's going to go, cleaning up where the dual springs go, cutting some material off the valve guides for clearance for the new rocker arms and cam, making my push rods. Probably more or less assembling it. There's not a whole lot more machining to do. Yeah, so we'll keep plugging along until these things are done. Maybe a couple more videos. I hope this one isn't too long. But anyways, thanks for watching. Check you guys next time. Jantic Journal.